if remember yesterday, we arrived till the end of the part dealing with the modeling, or let's say vibration analysis of 2 degree of freedom and damped. Here we consider an undamped free system, okay, with 2 degree of freedom that constitute essentially by, as you know here, two masses M1 and M2, two springs with a stiffness K1 and K2, and the displacement of the mass M1 is presented by x1, and the displacement of the second mass is presented by x2. What we did, just I wanted to review essentially the results that we arrived yesterday and before. First, we established the equation of motion by applying for each mass the Newton's law, right? We obtain a system here of differential equation. Okay, so in this system, we introduced again the concept of vectors. We introduced the vector of position, of vector displacement, the vector of velocity, and the vector of acceleration, and we rewrite this system using this vector, and we introduce here, by the same way, matrices. The first matrix that we introduced is called the matrix of mass and the matrix of the stiffness, okay? And by using the concept of the vectors and matrices, this previous system of differential equation could be actually written as simply the matrix of mass multiplied by the vector acceleration plus the matrix of stiffness multiplied by the vector displacement equal to 0. And we already discussed the general case. When we have more than the springs, we can introduce the damped element, and we can introduce also the external force. And this equation becomes general, that probably will include the stiffness of the damping, the matrix of the damping, and also the vector of force. Anyway, here we consider the simplest system, which composed by two masses and two springs, and we try to solve this equation of motion by using the complex method. The first result obtained from this the development is to calculate according to the determinant of this matrix, to calculate first the proper frequencies of the system. From the proper frequencies, we can move again to the corresponding vector x1 and x2. Once we calculate x1 and x2 and the two proper frequency, we can finally write the general solution of the 2 degree of freedom free and damped system. Okay, so today we will consider a simple example in which we try to apply what we developed yesterday. In this example, we will consider the same system, exactly the same system, with a spring with a stiffness K1 equal to 24 Newton per meter. Here, this is the stiffness K1, okay? Attached to the mass M1, attached to the mass M2 via the stiffness, or attached to the stiffness or the spring K2, and we have another mass M2. M1 is moving with the parameter x1, and M2 is moving with the parameter x2. Okay, here M1 supposed to be 9 kilogram or something, or whatever the unit. M2 1 kilogram, K1 is 24, and K2 is equal to 3 Newton per meter as a stiffness. Okay, so we have just to reproduce what we developed yesterday by the numerical value. Okay, the first thing is to, normally we have to establish the equation of motion. Okay, but this already done before, so we don't need to spend the time to rewrite the equation of motion because it is already given here. this using the matrix and the matrix of mass and the matrix of stiffness. Okay, so what we wanted to proceed just first to evaluate from this equation or to calculate the proper frequency. Okay, so of course we have to use this already developed equation with actually M1 and M2 they are given now, K2, K1 are given, so just we have to apply on this second order equation by using the numerical value. Okay, so we go back to our example. The characteristic equation that is given from the determinant. Which determinant? This determinant, in fact. This determinant. We are now applying determinant of D equal to 0. Okay? The determinant of D equal to 0 give us W4 minus 6W square plus 8. Of course, we obtain 6 and 8 based on this numerical value that we have to substitute in this second order equation. Okay? We obtain, if you calculate mathematically, we obtain finally the solution omega 1 square equal 2, omega 2 square equal 4, and from here omega 1 it will be equal to square root 2 radian per second, and omega 2 it will be equal to square root 4 يعني 2 radian per second. So here omega 1 and omega 2, which are equal to square root 2 and 2, they are called here as the proper frequencies of the system. Okay, so from the calculation or from this already expressed proper frequency, we can now evaluate the corresponding vectors x1 and x2. x1 could obtained from the system. Okay, here in our case x1, the corresponding vector x1 correspond to omega equal to omega 1 and could be obtained from this matrix multiplied by x1 equal to 0, 0, equal to vector 0, or the matrix of stiffness, which you know the matrix of stiffness هو كام هنا؟ The matrix of the stiffness, if you go back to the matrix of the stiffness, مكوناته هي ايش؟ مكوناته هي K1 plus K2 minus K2 minus K2 and K2. Okay, since here in our example K1 and K2 they are given, K1 plus K2 يعني 24 مع 3 27, so it will be here 27 minus K2 is minus 3. Okay, here minus 3 again, and here what we have K2 الظاهرة, I think, if you go back to the matrix of stiffness. The matrix of mass is composed M1 0 0 M2, or M1 and M2 here are 9 and 1. So we can calculate actually K minus omega 1 square multiplied by the matrix of mass. We find 27 minus omega 1 square is 2. Okay, multiply M1 is 9 here. Okay, so we obtain this first element of the matrix D. Okay, minus 3 we have here minus 3 minus 0. We find here minus 3, and here we have 3 minus 2. Multiply by x1. x1 is a corresponding vector to omega 1, which is composed, for example, by x11, x12. Okay, equal to 0. So from here we can calculate this system. 27 إلى 18 هي 9. 9 x11 minus 3 x12. We multiply the matrix by a vector. Here minus 3 multiply x11 plus 3 minus 2 is 1 multiply x12. We obtain a system. System هذا give us x11 equal to 1 over 3 x12. Okay, based on this relation between the elements of this vector x1, the vector can be defined actually as x1 مثلا نختار x12 equal to 1. Consequently, x11 it will be equal to 1 over 3 multiply 1. So it will be equal to 1 over 3. Here you have to know that x1 is not a unique, but is a multitude of vector, okay, which is supposed to be collinear vector. So it is represented by, or can be defined by 1 over 3 1. نفس الشيء if we want to calculate x2, we have to change only, instead of omega 1 it will be omega 2. omega 2 اللي هي 4 omega 2 square. Okay, so the second vector x2 correspond to the proper frequency omega 2. Here again we recalculate the matrix D with using omega 2 square equal 4 هنا 4. And we suppose that x2 is x21 x22. We calculate the matrix D here. We multiply by x21 x22 equal to 0. We obtain here again a system 27 minus 32 it will be equal to minus 9. Multiply x21 minus 3 multiply x22, and from here we obtain x21 equal to minus 1 over 3 x22. Suppose that x22 equal 1, so x21 it will be equals minus 1 over 3. Type what we obtained now. We obtained based on our calculation omega 1, we obtained omega 2, we obtained the corresponding vector x1, and we obtained the corresponding vector x2. These parameters for our system, they are enough to write actually the solution, because the solution, as we defined it before, it is function of omega 1 x1 omega 2 x2 اللي هي already determined in our example, right? So the general solution of the motion of the two masses is then given by xt, which is the vector position of the system, which is composed by the position of the first mass and the position of the second mass, can be calculated according to the previous expression of the solution a1 sine omega 1t plus phi 1 multiply هذه x1 that we already calculated. Where is x1? Here 1 over 3 1 over 3 1 plus a2 sine omega 2 اللي هي already determined multiply by x2 minus 1 over 3 1. Okay, باقي هالحين ايش؟ باقي we have to evaluate or calculate the constant of the solution. يعني a1 a2 phi 1 and phi 2. All this constant how can be calculated or can be obtained from where?
Initial condition.
Of course, always the constant of the solution اللي هما هنا 4 could be obtained from the initial conditions. وزي ما قلنا أمس طالما عندنا 2 mass, so that means the initial conditions will be equal تقريبا 4. Okay, so 4. Why 4? Because we have the initial condition for the first mass, which are the initial position, initial velocity, and 2 also initial condition for the second mass, which are initial position of the second mass, initial position for the, initial velocity of the second mass. So that's why we have here, normally we will obtain, if we consider the initial condition, for example, نعطي مثال, as initial velocity, suppose مثل انه initial velocities is 0, يعني initial velocity of the first mass and initial velocity of the second mass supposed to be 0. Okay, we apply this initial condition to our solution. Okay, يعني نحتاج ايش؟ نحتاج نشتق xt, we obtain x1 dot and x2 dot, and we replace by 0 because we consider a time equal to 0. We obtain, بالطبع اشتقاق الساين يعطينا الكوساين, وهنا الكوساين, and we replace time بصفر. That's why omega 1 and omega 2 will disappear in cosine. ونفس الشيء هنا. We obtain a system. From this system, look here, from this system we can eliminate one parameter and replace another parameter. We obtain omega 1 a1 cosine phi 1 multiplied by this quantity equal to 0. Of course, this could not be equal to 0 because they are the vector that we defined before. So necessary cosine phi 1 equal to 0, and from this the cosine equals 0. That means phi 1 equal to p over 2. Okay, we can replace phi 1 here, and we can evaluate exactly with the same manner mathematically. إذا إيش معنى إذا؟ معنى the same way we find phi 2 equal to p over 2. طيب هذا بالنسبة لphi 1 و phi 2. بالنسبة لل A1 and A2 we have to apply the solution on the initial position الحين. Okay, so we suppose that at time equal to 0, x0 will be equal to x1 0, x2 0. يعني هذه is the initial position of the first mass, this initial position for the second mass. We can now replace or substitute the initial condition in initial position on the solution here. طبعا phi 1 and phi 2 is already obtained. We replace here time بصفر. We obtain a system. How system اللي نلاقيه؟ السيستم وش موجود فيه؟ موجود فيه الكونستانت A1 and A2. phi 1 and phi 2 اللي هي already obtained. x1 0 and x2 0, they are supposed to be the initial position of our masses. Okay? assign phi 1 1, phi 2 1, phi 1 1, and we obtain finally a very simple system from which we can determine the constant A1 and the constant A2. Here you can identify أنه constant A1 and A2 they are obtained from the initial positions. Once we obtain A1 and A2, phi 1 and phi 2, we can now write the final solution of the equation of motion of our considered system. Don't forget that the system that we are dealing with is a 2-degree free damped system. Okay, x1 and x2 are the positions of the mass M1 and the mass M2. Of course, if we take some numerical value, I think K1 it will be anyway. So we have the numerical value of K1 and K2, M1, and in our example, definitively what we obtain in the end, we obtain a vector position. ايش معناها vector position؟ هو اللي that contain the instantaneous position of the mass M1 and the mass M2. يعني our system will oscillate the mass M1 and the mass M2 will oscillate according to this equation. X1t will be equal to this expression and X2 it will be equal to this expression. يعني when we look to the equation, we find that in fact the mass M1 is oscillating with two proper frequency. The first is square root 2 والثانية 2. And نفس الشيء the mass M2 is oscillating with a two proper frequency. That's in fact when we deal with the 2 degree of freedom, we involve here two proper frequencies of the system. لو كان السيستم فيه 3 degree, okay, so we have to define a 3 degree of freedom. 3 proper frequencies. Okay. So by this example, we can close this chapter. Why? Because simply, if we move now to more than 3 degree of freedom, or if we introduce actually another factor or another element in the system, like a damping element or an external force, the solution, of course, the modeling, it's easy to get. ما فيش حتى مشكلة. يعني we have to just to apply the Newton's law, and after that we consider the vectors and consider the matrices. We can easily arrive to the equation of motion by using the matrices and vector. لكن دايما زي ما قلت لكم, the solution it will be probably more complicated when we consider more element and more degree of freedom. Okay, so for the next time we will get or we will consider some other examples for other systems, and we try to proceed by the solution of equation of motion for this let's say 2 or 3 degree of freedoms, and probably we can include 1 or 2 other parameters like a damping element or some external force, and based on this parameters we can proceed by the different solution. Okay, do you have a question related to this part?
شكرا دكتور.
Okay, so I need within the couple time that معناها اللي باقي that I will send to you a link that is requested by the Deanship. فيه survey. I think you are able now to the switch link that I sent to you now. به هرسلكم الحين link فيه just wait. The course evaluation survey. أرسله لكم الحين على الواتس المجموعة, واتس الفايبريشن. Okay, so I أرسلته الحين. So try to take the maximum تقريبا ياخذ لكم 2-3 to fill the survey.